What are the four things we have? We already had the hoverboard, the two spaceships, and the NASA ticket. Now, for this particular sale, we have three more items and a special outfit for you. And with that, the updated golden ticket curiosity points. So, what are the four things you can buy today? Let us take a look at that. You can see over here. What are the four things you can buy today? So, the four things you can buy, first of all, is the skater shoes at 3.75 curiosity points. So 3.75 crores, that is, we're not longer talking in lakhs because this is the second sale. The previous one was in few lakhs, 84 lakhs, 14 lakhs, but this one has gone the next level. Skater shoes, the first one coming up. The next one we have is the Iron Man shoes at 8.5 crores. So 8.5 crores is the Iron Man shoes. You can hop with them. You can really go high up. If you want to hop, there is something else for that. That is Kangaroo shoes at 6.25 crores. So if you do not have enough curiosity points for Iron Man, this is the next best thing you can get, the Kangaroo shoes, and they can really take you high up and they can beat the gravity. And if you are in space, the next best thing is, of course, an astronaut suit that is going to take care of everything. The pressure difference that is there, or the air pressure is different, whether the temperature is different, or anything else is different. This is the spacesuit that you need, which can take care of all your different worries, and you can happily go anywhere you want in the Kalam Labs metaverse. So once again, the sale is live. Any student who buys any item during this sale, they will be announced live. So what you have to do, check the prices once again in the marketplace and send us a message on the WhatsApp number. You don't know what is the WhatsApp number? Go to the marketplace. It is available there. Any item you want or any previous item as well. If you do not yet have the Speedy Spaceship, this is a chance to get Speedy Spaceship as well, or the Shark Spaceship, or the Golden NASA ticket. What are the updated prices of the Golden NASA ticket? They are, what are the prices? They are at 15 crore curiosity points. So that has been three times, four times very high. This is because it has been very popular among the students. Now let us begin our today's topic. What is our today's topic? Our today's topic is about the only star which is present inside our solar system and the star that gives us life. We are going to attempt and go closer to this star. This is the survival sun. So we are going to talk about the survival sun and how can you survive on sun. So are you ready for beginning our today's topic and how can we survive on the sun? Let us start it by learning a few facts about the sun. What are these facts? Let us take a look. The sun. It is the heaviest thing that we have in our solar system with 98% mass. And the sun is not quiet. There are solar prominences happening on the sun. What else is there? The corona of the sun is 900 times hotter than lava. Imagine the hottest place on earth and then multiply it by 900 times. And that's not it. It has sunspots, solar wind, solar prominences, solar flares. It has everything. Very exciting things are found here on earth, and it is constantly spinning and moving. Where is it moving towards? It is moving on its axis and it is moving around the Milky Way galaxy as well. With that, let us start today's topic. And while we are solving all the barrels, you should keep in mind that wherever we are going, we are also going to announce all the students who are going to buy any assets today. Even if you are buying the speedy spaceship, we are going to announce it. Even if you're buying the shark spaceship, which is the least expensive and the first thing you can buy in the Kalam Labs metaverse, we are going to happily announce it and celebrate your curiosity points and your one step ahead moving in this process. So, speedy ship is also there, and hoverboard, you need those hoverboard before you can get the shoes. If you are not able to pick any shoes, get the hoverboard at 1 crore curiosity points. For example, now we will be going to the moon. Why are we going to the moon? Because that is where the round one is going to start. And we are going to see how the hoverboard can be really helpful here. So all the students who already have hoverboard, they're going to have a huge advantage in solving these battles. And if you do not yet have it, this is the time to get it. Messages on WhatsApp quickly. What is the thing that you want? And we are going to announce it. We are waiting for your reply. So please let us know as soon as possible. So we have reached on the surface of the earth, and this is the time that we are going to start our first round in one, two, and three. Here we go. I have given you the controller access, and now you are free to explore the terrain of the moon with your hoverboard in the next 7 minutes and 42 seconds. The questions are about surviving on sun. Let us see how can we survive on sun, all the information that we are going to need. What are the different things we need to know before we survive on sun? The very first thing we know is everybody knows the sun is super hot. But do you know that the sun is not hot just like other planets? If you go inside a planet, it is going to be very hot from inside. And if you go outside a planet, it is going to be very cold. Unlike that, in the sun, what happens is there is this surface. If you go inside the surface, the temperature is going to increase. But if you go outside, that is, if you are going up, if you're launching up, then also the temperature is going to increase. And nobody knows why this happens. Even the scientists who are studying the sun, they're not sure why this happens and why is the atmosphere of the sun is more hotter than its surface. It's crazy. So sun is filled with these things. If you want to venture out to sun, if you want your spacesuit and if you want to go inside the sun, you want to survive on the sun, you need to know this piece of information, which is the best place to go. You might think we want to go to the atmosphere because that will be the coldest. No. The atmosphere is more hotter than the surface. Imagine standing on the surface of sun is more colder than being in the atmosphere. That's how crazy the sun is. And what else is more crazy about the sun? Let us take a look. What else do we have over here? The sun, I told you that the sun spins. So, when we are talking about, there are two types of motion that the sun does. We have a year on Earth, which is 300 days. A year on other planets is sometimes 88 days. Sometimes it is more than that. Sometimes it's like 20 days. Sometimes it is 200, 300, 1000, 2000, 8000. Who knows how many years it may take, depending upon how far away we are. But there is an interesting thing that if you want to see a year on the sun, what will be a year on the sun? The time it takes for the sun to go around the galaxy. We are no longer talking about a solar year, we are talking about a galactic year. So, how long is a galactic years? It is at least a few billion years It is going to take time. No more 1,000 years. It is going to take million years of time. And if we talk about how old is the sun, how has the sun been carrying out these things? It has been carrying it out since the time it was born, which was 4.5 billion years ago. That's how the old is the sun. Very, very old. The kind of questions you can find inside the barrels, the structures of the sun. So what is the structure of the sun? There are many layers. It's not just a ball of gas. There are many, many layers. What are these layers? First of all, inside the sun, if we talk about, there is a core, there is a nuclear reactor happening. We have these nuclear power plants. They all are using the same type of energy that the sun is using, and that's a natural and the biggest nuclear reactor we have in the entire solar system. What is happening inside this nuclear reactor is, imagine there are 70 about 70 hydrogen bombs going in a single second. But that is not what is happening inside the sun. That is what is happening inside the on the surface of the sun, which is the coldest part of the sun. And even if that is so hot, imagine what would be happening inside. Inside there is millions of degrees, the temperature is there. The atoms of electrons, the atoms of hydrogen are moving so fast away. They are ripped apart. Their electron is going somewhere else, their proton is going somewhere else. So they are no longer an atom. It's no longer stable. It's ionized. What are ions? These are things where things are plus and minus. Electron is somewhere else, proton is somewhere else, neutron is somewhere else, even if it is formed, or it is going to break down once again. So things are very plus and minus, nothing is stable. And this type of matter, this type of state of matter is not known as a gas, a liquid, or a solid, but it is known as plasma. What is plasma? You heat up air. You start from solid, you heat solid, you give it some heat temperature, it is going to become liquid. You heat the liquid, it is going to become air, gas, water vapor. You heat it even more, and then you are going to get what exactly? You are going to get plasma. And this reminds me, Abhishek asked a wonderful question a few days ago. Abhishek asked, why does the sun does not goes out of the oxygen? This is why, because the sun does not really need an oxygen to burn. It is not on fire. It is having a nuclear core inside it, a nuclear reactor inside it. Things are happening differently. It is not on fire. For fire, we need oxygen. If we do not have oxygen to burn a wood, if we do not have the oxygen near our homes, if we are turning on the gas stove, that is called fire. For that, we need oxygen for combustion. But for this thing, for nuclear reaction, that is fire, that is not fire, that is something else. That is a nuclear reaction, which is known as nuclear fusion, when two atoms fuse together to form a bigger atom. So that is why it does not needs oxygen, and it has some oxygen which is going to get converted into other gases, other heavier atoms. So there is nothing special about oxygen inside the sun. It is as same as having beryllium. It is as same as having carbon inside the a star, or having some other material. There is nothing special about oxygen. It is going to get formed, and the next step is going to get more heavy atoms, until we reach iron. And then there was the other question, which was about galaxies, which we are going to answer in the round two. Let us see what else do we have in round one remaining. We first of all just have 40 seconds remaining. That's very, very less time. So there is one interesting question which is about what rains on sun. So of course not water, because there are no clouds. There is atmosphere, which is corona, or the chromosphere, but clouds are not there. So what is inside the sun? Plasma. We have here water on earth. We have water cycle, and then water comes down. Same thing happens on Titan. Methane goes up, methane comes down. It's everything is made up of methane. On sun, we have plasma going up. Why? Because the sun is made up of plasma. So plasma goes up, plasma comes down, and then there is plasma rain. So things rain on the sun too, and you should be very careful on the sun. And that brings us to the end of round one. I am taking back the axis. So round one is over. Round one is over, everybody. We are going back somewhere else, and we are leaving this place. We are going to get outside, and before we get outside, let me remind you, The sale is still live and it is going to get over soon. So, all the students who want to buy something, this is your time and you should buy it right now. The sale is live. Use your curiosity points and buy them to get anything you want. All these items are on sale right now. Then the prices are going to increase, and if the prices are going to increase by next week, it's not wonderful. So use all the curiosity points you have saved till now and buy them. Message us on WhatsApp because then the prices are going to increase. And if you want to score more curiosity points, that means we need to solve more barrels. The barrels are filled with questions. The more barrels you solve, the more points you have, and the more number of days you solve them continuously, you're going to have a streak. And if you are on a streak, you're coming for 2 days, 3 days, 4 days in a row. That is how your points are going to get multiplied too. So remember to come every day if you want to gain these points faster. That is how some of the top scorers have been doing. And let me say, who else do we have with us here? We have Gracie and Abhishek and Shaurya and Pranav and Samradni. So, good evening, all of you. And now we are going to begin our round two. Where is our round two placed? Round two is somewhere here only. Our round two is inside the space. So, we're going to learn more about the sun. What are we going to learn more about the sun is? Let us take a look. So here we have more things related to the sun, and this time we're actually going to go inside, more inside, not just from the surface. We saw from the surface what was happening is the surface is weird. How much is happening? How much is happening on the surface? I told you that the surface is the coldest part of the sun. So let us look at the sun over here. The region that we see, this is known as, what is this known as? This is known as the photosphere. Where does the word photo comes from? It comes from the word photon, which is the particle of light. So this is the photosphere that we see from our eyes or even in our Kalam labs. This is the photosphere, the surface of the sun. But you cannot walk here because it's not solid, it's plasma. Anything which is outside, so you will be able to see a very, very faint halo that is around the sun, and this is known as the corona. If you were watching our previous NASA scientist session with Dr. Patricia, you might be aware what is this outer region of the sun known as. What is the most outermost layer of the sun known as? And I'll give you a hint that it starts with the letter C. So, what is the most outer layer of the sun known as, which is also visible over here in a bit red color?
Corona OP. Corona OP.
Yes. And why is it known as corona? Because the word corona actually means crown. And when we see the sun during a solar eclipse, this is how it looks. So let me show you how the corona looks. We cannot see it from our eyes, but we can only see it during a solar eclipse. And during a solar eclipse, what did people saw? The old people, they were able to see that the sun is not how it appears us to be. So let us take a look of how does this corona looks like in this picture. So this is the sun's corona. It is white in color in this image, but it can be of any color that we want. So over here, if you are able to see on the screen, this is how the corona of the sun looks like. You can see it. What is the stuff which is black in color? What is this black entity which is hiding the sun? What is this
uh,
black?
Corona or Moon.
Corona is the white entity.
Moon
This is
OP. Moon OP.
this is
Moon.
this is the moon. So moon is hiding because during a solar eclipse, moon comes in front of the sun. This was the sun, but now moon has come in front of the sun and it has hidden it completely. And all this region that you see around it is the corona. Something more interesting happens outside this corona is, what is that? That is the solar flare. What is the solar flare? That is a very scary thing. Let us take a look at a solar flare and how does it looks like. Solar flares are very very scary, and they are very very big as well. They're not small. These solar flares are very big, and we are going to see one of the pictures of a solar flare. So let us take a look at how do these solar flares look like. Okay, so here we go, and this is how these solar flares look like. So sometimes you can see something is coming outside. If you see over here, this is the sun, and sun is not at all stable. You can see it is rotating, and also if you see in this region over here, something is coming out in this region, right? Something is being formed in this region. If you see over here, something else is being formed here as well. So what are these things? These things are the prominences, and solar flares are even more bigger than this. Even more energy is being released. Prominences are more cool, they form loops, and solar flares can extend even more. They are even more bigger. We are not able to see them entirely in this, because in this the camera is focused only on the sun. How can we see them? We can see them when we zoom out. If we zoom out, then we will be able to see a solar flare, and that is going to be very very huge. Very very huge solar flare. So let us see how do these huge solar flares look like, which are very big in size. And they are only seen, how are they seen? They are only seen when we are seeing them from a different type of filter. If we are not using a filter, then we will not be able to see them. So let us find a picture in which we can see a very very big solar flare happening. And then there is something else too, which is known as coronal mass ejection, and that is also very very big. So big big things the sun throws out very very often. So let us take a look at something else we have over here. This is how the coronal mass ejection looks like, something which is very very big. So let us take a look at it once again. What is happening over here? This is the sun. So we are not talking about a solar prominence, like not something small, not the loops. We're talking about the big thing, very very big thing. So let us take a look at the big thing. You see how it throws out a big explosion of gas? This is how a solar flares or a CME, coronal mass ejection, looks like. Throws out very explosive. How much energy? Something like 70 hydrogen bombs blasting at once. And then it throws it out. And it travels and travels. It may travel so much far away, it can even reach on Earth. And when it reaches on Earth, what happens is we start having auroras. This is how auroras are formed. Otherwise, we would have no auroras at all if the sun was not such active thing. And this is how we are able to see so many things here on Earth, and they are all related. Now that we have learned a little bit more about the sun, let us start our round two. And in this round two, we are going to solve barrels which are present inside the space. So, near the four inner planets that we have, you have to solve them. They are present near the Mars, near the Earth, near the Mercury, and near the Venus. So, as I was saying, in this time we are trying to go inside. We have seen what happens outside the sun. Let us try to see what happens inside the sun. If you go inside, outside violet things are happening, solar flares are there, prominences, corona is there, solar eclipse, we can see it that time. Inside the sun, the sun is going to be completely black. And that may seem weird. Why is the sun black? It should be white, but it is actually black. Why is it black? Because we know that a photon of light takes 8 minutes and 20 seconds from the surface of the sun to reach the surface of the earth. But do you know how much time it takes for a photon of light which has born a photon of light which has born inside the core to reach the surface of the sun. I'll be taking back the control axis because I want to hear your guesses, okay? So I want to hear your guesses. How much time do you think the photon of light is going to take from the core? It has to travel from the core till the surface. So it's not very much, it's actually less than the distance that we have between the sun and the earth. So how much do you think it is going to take time? 8 minutes, 4 minutes, 2 minutes, 1 minute, few seconds, few hours? What are your guesses? How much time is it going to take?
Going 8 minutes.
8
8
minutes. 8 minutes.
minutes. 8 minutes.
Some
8.
students are saying 8 minutes, but my question is not from sun to earth. I am asking from inside the core of the sun to the surface, like inside the sun. It is born inside the sun. So from there to the surface. We are not yet talking about the earth itself, okay? So let us see if the answers change now.
Some minutes.
8 minutes itself. 3 minutes. 10 minutes. 10 minutes.
10
10
minutes,
minutes.
2
1
minutes,
minutes.
2 minutes like Maggie. So I'm giving you back the access control. Now you may solve these other questions which are there. So I'll tell you how much time it takes. It takes thousands of years. Why? This is also the reason why the sun is black from inside. What happens is there is the temperature is very high inside the sun. So because the temperature is so high, what happens is all these electrons or protons are moving like tuk 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 tuk. They're all bursting into one another, colliding, forming atoms, breaking atoms. Very violent place. Most violent place in the solar system is inside the core of the sun, inside the surface of the sun. Now what happens is once a photon is born, we are only able to detect a photon if it hits our eyes, if it hits our camera, any receptor, any detector. If it does not hit, we are not able to see the light. What happens inside the sun is this photon, before reaching our eyes, is going to hit a million other electrons, tuk, 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 tuk. And it is going to just, back and forth, back and forth. It is going to hit back and forth before actually, by luck, coming to the surface. So that small journey compared to how far away the light of star goes, we are able to see light that is coming from 13 billion light years away. Light that has been traveling for billions and billions of years, we are able to see such far away galaxies and stars. But inside the core of the sun, when the distance is so small, because there is such violent activity, it actually takes 1,000 years and sometimes even a million years for that photon to come. So we say that when our eyes are seeing these electrons, seeing these photons, it is about 8 minutes old. But in actual reality, if there is a way to find the age of the photon, it would be billions and millions of years old. Who knew when it was born? Because we are not measuring the time it takes from the core to the surface. So the photons that you see, which are coming from the sun when you are taking a sun bath in the morning, they are millions of years old. They started their journey when there were dinosaurs here on Earth. And dinosaurs came, dinosaurs went, all types of other species of human came and went. We are in the 21st century, and that photon is just going back and forth, and suddenly it comes out to the surface. It's like, now it's my time, and then eventually it hits your body, it hits your eyes, and you are able to see. So photons have a different type of life. Until they hit something, their life continues. If they are able to hit something, your eyes, your skin, you will absorb that energy. They are part of you now. So that is about the photons, and that is why inside the sun we are not able to see anything. It is completely black. Why is it black? Because the light is not able to hit our eyes. It is just hitting back and forth around the electrons, protons, neutrons, other type of subatomic particles except your eyes. So it's all black, and the pressure is also very high. It's how much pressure can you feel? Imagine having many tons of iron on you. That is how much pressure you are going to feel inside the core of the sun. The pressure is very high, and that is why it can counteract the gravity as well. And then there is one more question about the mass. So if you are weighing, let's suppose if we have an object that weighs 100 kg over here on Earth, then if you're talking about moon, it is going to weigh less, something like 16 kg, 15 kg, because on moon it is very less, one sixth of Earth. If we have something here on the sun, if we have an object which is weighing 100 kg on earth, how much times do you think it is going to weigh on the sun? It is going to become 3000 kg. Very heavy. So the first thing you need to make is make things very very lightweight. Even if you take 1 kg, that is going to become 280 kg or something. So it is very hard to survive on earth because the temperature is high, the gravity is high, there is plasma rains. And how can you save yourself from the plasma rain? It comes out of a solar flare. So you should be aware of the solar flare and prominences. There is a very specific place on the sun where all these things erupt from, and that is a sunspot. Now, sunspot looks a black, dark spot on the sun. Sun is so bright, yet it is full of mysteries, and it has dark spots which are known as sunspots. And these are the sunspots where the magnetic field lines are emerging from, or they're going inside. Now, what happens is these are the places from where solar flares come out. Those explosion, 70 hydrogen bomb explosions are coming out of these sunspots. And also the plasma rain is going to come outside from here only. And that is why you should just be aware of these sunspots. Like, do not go near them. And they keep on moving and moving and moving. So even if you make a permanent base somewhere around the sun, because the sun is also moving, the equator of the sun is moving, poles are moving, everything is moving with a different speed, and nothing is solid. So it is actually very hard to live on the sun. And so many other questions you may be finding. And yes, how much time do we have? The time is almost over, so I am taking back the access control now and reminding you once again regarding the sale. The sale is still live, so let me just remind about you. What do we have over here? We have multiple things, and let us take a look at them for all the students who are joining us right now only recently. Let us take a look at what do we have over here. So the NASA Golden Ticket, the Speedy Spaceship, Shark Spaceship, the Hoverboard, the shoes, whether it's the kangaroo shoes or the Iron Man shoes or your skater shoes, all of the things are on sale, and this is your time to get it before 7 p.m. The sale is going on. You just have to message us on WhatsApp. You have to use your curiosity points. What are curiosity points, you're asking? Curiosity points are the things that you get when you solve the barrels. So the points that you see, they are not going anywhere. If you're coming on these sessions one by one by one, so all these points are getting collected, and you can actually use them to buy these things which are going to help you solve these barrels much faster, and they will also help you interact with a NASA scientist. So all these things we have, and some more interesting facts which have been left unanswered till now. So before we go there was a question which was asked by Abhishek. So if you also have some questions, you can message them and we'll take them if they are interesting enough in our live classes. So the other question which Abhishek asked was related to the magnetic field of galaxies. Now, what is a galaxy? Galaxy is a very big thing. Galaxy is the bunch of stars. All the stars that we see inside our in the night sky, they're actually part of the Milky Way galaxy. So let us take a look. How does the Milky Way galaxy looks like? So this is how the Milky Way galaxy looks like. First of all, I'm going to show you how does it looks like from here on Earth, and then I'm going to show you how it may look like from space. So we're going to take a closer look at three pictures over here, one by one. So let us first of all see how does the Milky Way galaxy might look like from which place. We're going to say how does the Milky Way galaxy looks like from Hanle, a beautiful place which is in the Ladakh. So this is how the galaxy looks like from naked eyes there. So we're not talking about telescope or anything, no. We are talking about naked eyes over here. So how does it look like? You can see it on your screen. This is the observatory, the Himalayan Chandra telescope, and this is how it looks like. So this band that you are able to see, this is what the Milky Way galaxy, the core of Milky Way galaxy it is. There are all these other stars, they're not so bright, but this specific thing is so bright. Now what exactly is this thing? Then we have another picture for that. And in this picture, you can see how the Milky Way galaxy actually may be like. If we zoom out, if we go outside, so we're no longer talking about from the perspective of the sun. We are talking about from the perspective of the Milky Way galaxy. So let us take a look at that. And this is how it may appear like. Over here, if you see it, so here we have, just give me a second, and okay, yes. So this is how it may appear like. So stars in the outer regions go 220 kilometers per second. This is what we learned in the very beginning. How much time the sun takes to go around the galaxy. So this is where the sun is, and this is how it is going to take so many billions of years to complete 1 year, which is known as the galactic year. It is going to complete its 1 year, and then 2 year, 3 year, 4 year. So in 1 billion years, only four orbits. And how many orbit it has completed? Something like 17, 18. That's it. And imagine how much orbits we have completed around the sun. That's very quick. Now what happens is, this is how the galaxy might look like. Now in our if you're talking about magnets, so it depends upon what is the magnetic field. If it is both plus and minus, sometimes it cancel out, or it can be very weak. So there is no plus and minus, but there is the south pole and the north pole in the magnetic field. So what happens is, in the entire galaxy, some things are moving in one way, some things are moving in another way. There are also things which are on top, things which are on bottom. So the galaxy is actually a 3D thing, and there are so many stars of different things, that the magnetic field of the entire galaxy is there, but it is very weak. The question of the Abhishek was that, is there any galactic magnetic field? Do galaxies have magnetic field? If yes, what kind? If no, what kind? Why don't they have any magnetic field? So they do have some magnetic field. It has been observed. How does this magnetic field looks like? But the thing is, it is very weak. The most magnetic thing, if we are searching inside our universe, is things which are like magnetars. And if we are looking at the field of our own galaxy or any other galaxy, this is how it may appear like. So we have a galaxy, and then the magnetic field is going to extend out. And this is something that our eyes cannot see, no telescope can see. This is only like made up. This is not real, because magnetic field lines cannot be seen by any telescope, no telescope at all. So this is what scientists think, that a particular galaxy may have this type of magnetic field, all these lines. But this galaxy is very far away, and the other thing is, the magnetic field is also very weak. So when you combine two things, you will understand how sensitive and powerful our telescopes are. Even before then, James Webb Space Telescope, such powerful telescopes are there, which can see the magnetic field of galaxy, which is weak, and the galaxy is also very far away. So imagine the kind of discoveries telescopes like James Webb Space Telescope can make. And if you want to see how does the magnetic field of Earth looks like, so magnetic field of Earth is, let us take a look at how does the magnetic field of Earth looks like. So this is how it looks like. And okay, yes. So just like how we saw in the video previously, this is how the magnetic field of this Earth looks like. The sizes are not to scale. The sizes are not equal. If you see over here, the sizes are not equal, because the Earth is way more smaller than this compared to the sun. So if the solar wind is coming from the sun, all these particles are coming from the sun. What happens then? Then the thing that happens is that our Earth has a magnetic field, and this magnetic field is able to throw them out. And when it is not able to throw them out, they enter and then they form aurora. So this is what happens. when the solar wind is able to reach sun. Sun is very exciting and a very very active place. It's very active. And that was our today's session on the sun, on the survival of the sun. I hope you enjoyed today's session, and we will see you once again at 7 p.m. So, if you do not yet have enough curiosity points to buy anything, you can come to our other sessions. They're happening from 10 a.m. in the morning till 10 p.m. in the night. You can come anytime you want and earn more curiosity points. And I want to thank everyone who was joining. So, Akshat and Samradni, Shaurya, Gracie, Abhishek, all of you, thank you for joining. We are going to end this session, and that means we are going to do our 10-second countdown in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. This is the time to celebrate the science, the interesting science that happens around us. We love science.
Science! We
Sophie!
love
We love science,
science!
Sophie!
We
We love science,
love
Sophie!
science!
We love science.
Thank you everyone for joining and celebrating science with us. We'll see you very, very soon. This is Esther Roxy signing off.